Section 3.1, derivatives of polynomials and exponential functions. So we're going to learn how to find the derivative of polynomials and for exponential functions. But before we do so, let's recall some algebra stuff, especially those that deal with exponential exponents. So if we have the nth root of x to the m, this can be rewritten as x to the m over n. If you have x to the negative m is 1 over x to the m, as you can see. If you have, for example, 1 over the nth root of x, something like this, what can we do with this one? You can rewrite it first as 1 over n, because there's a hidden 1, and then you can bring it up as negative 1 over n. These are important to know. And I'm assuming you know the other properties of exponents, such as x to the m times x to the n, that we reviewed the first 2 weeks, and the other ones. That's the first thing we need to review. Also, we need to recall, we proved last time or the time before, what is a derivative? Where did it come from? And so we said the derivative of the function f of x, using the notation f prime of x, is the limit of the x plus h minus f of x over h, all divided by h as h goes to 0. That's called difference quotient. And there was another one. You can use either one. I usually use this one. This was the definition here. What we are going to do is learn some rules today, but before we learn the rules, the first function we start with, if the function y is a constant function, c, constant. Constant means any number. It could be any real number. What would be the derivative for this? What is y prime? Well, let's see what y prime is going to be. To do that, let me first rewrite c as cx to the 0, assuming x is not 0. So you can rewrite it as cx to the 0. That's our function f of x. So what I'm going to do is find the derivative for this function, f prime of x, using what I just wrote up there, limit as h goes to 0. F of x plus h, so you're going to replace the x with x plus h to the 0 minus the function itself, cx to the 0, all over h. This equals limit as h goes to 0. Here, what we get, the x plus h to the 0, assuming that's not 0, so that's going to give us 1. So I got c minus x to the 0 is another 1 over h. Remember, h is not 0, but it's approaching 0. So what I got on the top, we got 0 on the top over h. So what I'm getting here is the limit as h goes to 0 of 0, which is 0. So that tells us that the derivative of any constant, so if y equals c, y prime is 0. So the derivative of any constant is always 0. Any questions about this? Okay, so now, if no questions, someone said, why did you just get C alone rule? That's the constant one for any constant function, and you will see how we apply it in a minute when we write polynomial functions, because polynomial functions contain constant terms. So we need to know what is the derivative for the constant term. Okay, so now what about if it's not a constant term, something non-constant? What happens? Although the constant is going to be a special case of it. So if we have if y equals a function written in the form y equals x to the m, then what is y prime? What is y prime? Y prime is you bring m down, x to the m minus 1. So you multiply the exponent by whatever number you have in the front and subtract 1 from the exponent. This is called the power rule. Power rule. Power rule. Okay, so the good thing about the power rule, when you are asked to find the derivative from now on, you don't have to use the main definition of the derivative. That will save us a lot of time. It will save us a lot of time. So if we look at the quick example, y equals x squared, what would be y prime? What is y prime? Well, it says you multiply the exponent by the number in the front, which is 1, so you get a 2. Then you subtract 1 from the exponent. So y prime would be simply 2x. That's called example 1. X to the 6. How can we find the derivative for this? Try it. Just write it on your own on your paper. It should be quick and easy. So y prime, if you're done, so we get 6x and subtract 1 from the exponent. So y prime is 6x to the 5th. Do you guys see that? Okay, Tycho is sharing his answer, 6x to the 5th. How about if we throw a number in the front, say -1/4 x to the 8th power? What would be y prime? You may share your answer on the chat. Already he got the answer, Tycho. Okay, assume everyone tried. So -1/4, bring the 8 down, multiply it by that and subtract 1 from the exponent. So y prime equals by 4 1 by 4 2, so that's a -2x to the 7th. So notice if you had to go through the limit as h goes to 0 of the difference quotient, that will take a lot of time to calculate the derivative for this. To make it more fun, let me write another one. 1 over x to the 10th power. What would be the derivative for this one? Okay, when you finish, I'm going to write the next one. Let me add a note here, a note next to this. What happened here, if there's a number in the front, it's not going to affect anything for the rule. If you have a constant a times a function, you can take the constant out and simply find the derivative of that function. Or you can just multiply 8 by -1/4 as I did. Keep that in mind. So now we have these two questions. Okay, thank you, Tycho, for sharing the answers. So let's do the number 4. We can't find the derivative for this because it's not written in the form x to the m. It has to be in this form. So to make sure you can write this in this form, you bring this up, becomes -10. So first, that's at the algebra step, the rewriting step. Then now it's ready to be differentiated. So you bring the negative 10 down, x subtract 1 from the exponent. And that's what Tycho got. But note something, as I said before, we don't want to see any negative exponents in final answers. So I'm going to bring that one down to make a positive exponent. See? So that's what we have. Two minutes for the next one. Let's see if you are able to progress on number 5. Let's do this one. What we can do, the square root of x is x to the 1/2. You rewrite it. Is it in the form x to the m? Not yet. But we know a property from algebra that says if they have the same base, we subtract the exponents. And that's what happened. These two, they have same base. So what we can do, we can subtract the exponents 3 minus 1/2. And if you combine the top fractions, you get 5/2. All this is just algebra, no calculus yet. Now you can say then y prime, bring the 5/2 down, subtract 1 from the exponent. Y prime is 5/2 x to the 3/2. And that's what some of you got. Any questions about this? So now, what happens if you have more than one function or more than one term within one function? Say we have a f of x plus or minus g of x plus or minus h of x plus or minus da da da, and we need to find the derivative for all this sum or difference or a combination. To find the derivative of a sum or difference, simply find the derivative. So the derivative of the sums is the sum of the derivatives. So you just simply find the derivative for each one of them, like so. And if we like to look at some example on this, let's say find y prime if, let's say, y equals 2x squared plus 3x. So how do you find y prime? You multiply the 2 by 2 first by the power rule. 2 by 2 is 4, and subtract 1 from this, which is 1, plus there's a 1 there. 1 times 3 is 3, and subtract 1 becomes x to the 0. So always, if you're finding the derivative of a constant times x, the answer will be a. So y prime equals 4x plus 3 is the derivative for the first one. Let's look at another one. X cubed plus x minus 5. Notice something here. The first one, what's the derivative of x cubed? Can someone participate over the chat? Tell us what it is. Or say it up. Just for x cubed. 3x squared, yes. 3x squared. What's the derivative of x? Derivative of x is, see, when you find derivative of this, you bring the 1 down, 1 minus 1. So it's 1. Minus, what's the derivative of 5? 0, because that's a constant. And that's what we started with. Because one of you asked, why do I need to know that? See, that's where we use it. So that's 3x squared plus 1 as the answer. So now I'm gonna give more examples, but I want you to try it. But you're gonna work together on this as a group. This is one of them. Please write it down. Make it more difficult. 2 minus x to the negative 1/2 all squared. Here up there, I'm gonna recall a formula we used a lot before: a minus an a plus b squares, a squared plus 2ab plus b squared, and a squared minus 2ab plus b squared, if you need it. Another one, you're gonna be trying it. Write all of them down. Y equals 2x plus 3, 5x plus 1, 6, yx equals x to the 8 minus x to the 6 over the square root of x. So what I'm going to do is use the breakout rooms. Now we're going to go over these questions one at a time and show you how we do this. Now for the first one, some people, they try to find the derivative of this one and the derivative of that one. It doesn't work out this way. It has a formula we will learn in the next section. And the only thing we have is to distribute this out. X to the 4th minus multiply out x to the 3rd, 11x squared. That's what y is. Then we can find y prime. It's ready because all these functions are written in the form x to the m power. The derivative of x to the 4th, 4x to the 3rd, next one 3x squared, and the next one 22x. And it's done. Nothing else need to be done. The next one, do not find the derivative of the inside or bring the 2 down. In section 3.4, I'll show you a shortcut, but for the meantime, the only tool we have is to expand this. To get rid of that square on the top, we need to expand it. So how do you expand it? You can multiply 2 minus x to the negative 1 by itself twice, or you can expand using a minus b squared formula right above it in the box, which says take the 2 square it minus 2, the first one times the second one, plus the next one square. So then y equals 4 minus 4x to the negative 1. And this one you multiply exponents. So far, no calculus yet. Then what is y prime? Y prime, derivative of 4 is 0 because it's constant. Bring the negative 1 down, becomes positive. Bring the negative 2 down. And again, that would be the calculus part. And now one more step to make sure no negative exponents. You bring the x squared down, x cubed down. The next one, as a hint, and I'll give you 3 minutes to try it, try to multiply this out, FOIL it, then find the derivative. And for 6, there's 2 methods to do this. You can rewrite the denominator as x to the 1/2, and then you can either split or bring it up, x to the 8 minus x to the 6 times x to the negative 1/2. And before we find the derivative, we multiply these out, 8 minus 1/2, 6 minus 1/2, and try to finish it now on your own for 3 minutes. Okay, let's go over that. Hopefully everyone tried them. So here when you multiply this, you get 10x squared plus 2x plus 15x plus 3. We may combine like terms first, the middle ones, before we find the derivative. Then it's ready to be differentiated as 20x plus 17 plus 0. So that would be the answer to number 5. For this one further step of algebra or arithmetic here, 8 minus a half, 15 halves, 11 halves. Then y prime is 15 over 2x, subtract 1 from the 15 halves, becomes 13 halves. 11 over 2, 9 halves. Any questions about this?
I was curious about number 6.
Yes.
Are you not multiplying the negative 1/2 to the 8 and the 6?
We did. So as a note,
Oh, I see.
when you multiply x to the 8 times x to the negative 1/2, they have the same base, so you add the exponents. It becomes like that.
Right, I see.
Other
Thank
questions? As you notice, I would say 70% of the work in the calculus class depends on algebra. That's why we spend the first week just reviewing the algebra stuff. Very important. If you can't manipulate the stuff, rewrite things to make it look like what you need or make it easier for you, it would be difficult to do the calculus part. So now, part of this section, the other part, is the exponential part. Exponential functions, derivatives. So for the meantime, we will just give you, if you have the exponential function y equals e to the x, then the question is, what is y prime? Right? What is y prime? So to do this, we will prove also to you why this works later on, and then we will look at the general form in section 3.4. So for the meantime, if y equals e to the x, y prime would be itself, provided it's just ex, not e to any function. So how do I apply this? Let's say we have y equals 5e to the x. We need to find y prime. This is another one. I'm writing more examples. So it's only one formula for ex here, but at the same time, I'm trying to integrate what we learned so far. For the first one, it's 5 constant, the derivative of ex is ex. For the next one, 8 constant, derivative of ex is ex, minus 2x plus 0. For the last one, we need to distribute first 5x minus 5e to the x. Then y prime is, keep the 5x is 5, minus 5, derivative of ex is ex. So this is a special part of exponential functions. So no matter what exponential function we use, we're going to see really in section 3.4 how to deal with them. What about if it's not e? What about if it's 2 to the x or 5 to the x? How to deal with that? Or e to some other power, e to the x square. Okay, we're going to see that. Now, if you are curious about why the derivative of ex, again, any derivative we find, it comes from the main definition of derivative. So remember, we define as the limit of f of x plus h minus f of x over h as h goes to 0. That's the derivative. And we have, I'm not sure how many of you learned this before, we have, this is the definition of the number e. E is defined as, in the definition e, that the limit of e to the h minus 1 over h as h goes to 0 is always 1. So the number e is defined so that this limit is satisfied. And you can run some testing using, the e is about 2.7 to 2.71. Using table values of tables for e to the h minus 1 over h as h approaches from the right side and left side, and you will see that the value is approaching 1. And later on we'll teach you another way to prove this exactly 1. But if I want to apply this to the function f of x equals e to the x, then we find the limit as h goes to 0 of f of x plus h, so e to the x plus h minus e to the x over h. And how are we going to prove that this is e to the x? We may rewrite the top one, e to the x times e to the h, backwards of exponent properties, minus e to the x over h. Then we can factor e to the x out, which can be taken outside because it's independent of the limit h. And what is left inside? E to the h minus 1 over h. So this is e to the x times, all of this is this one, it's 1. And that's why we get e to the x. Anyone has any questions about this section?
Are we going to need to know the limit definition of a derivative for the exam?
You mean this one in the box, the one you see on the screen?
One above that.
About this one?
Yes, that one.
For sure. Very important.
Yes.
Yep.
Yeah.
This is for especially previous sections. Like, the 2.8, I think. Any other questions?